Yeah. So we are doing similar triangle stuff problems. Let me explain one problem which is related to numerical problem. P and Q are the points on the sides AB and AC respectively of a triangle ABC. Look at this diagram. Actually, this is nothing but fill in the blank, or they may give for short answers also. P and Q are the points on the sides of AB and AC respectively. P and Q are the points on the side AB and AC respectively. If AB is equal to 12, AP is 12, 2 centimeters, I'm sorry, PB is 4 and AQ is 3 and QC is 6 centimeters. So from this he is asking, prove that BC is equal to 3 times PQ. BC is equal to 3 times PQ. How to do this one? So here prove that we have to prove RTP. BC is equal to 3 times PQ. Consider triangle APQ and triangle ABC. So what you do is AP by PB you take. AP by PB is equal to AQ by QC. What you will get? AP by PB is nothing but AP by PB. 2 by 4 is equal to AQ by QC. AQ is what? 3 by 6. 1 by 2. So here AP by PP is equal to AQ by QC. So we are getting both are equal to 1 by 2. Now both are same. What I mean to say is AP by PB is equal to AQ by QC. Ratios are same. So by converse of DPT, if a line divides the other two sides in the same ratio, therefore by converse of DPT, PQ is parallel to BC. If a line divides the other two sides in the same ratio, then that line is parallel to the third side. PQ is parallel to BC. Therefore, are you getting my point? AP is equal to 2 given, PP is equal to 4 given, AQ is equal to 3 given, QC is equal to 6 given. So AP is nothing but 2. 2 by 4 is half. AQ by QC is nothing but 3 by 6. That I am writing directly 1 by 2. So by converse of DPT, converse, what is the converse of DPT? If a line divides the other two sides in the same ratio, then that line is parallel to the third side. These are the other two sides, this is the third side. Therefore PQ is parallel to BC. Now, see, this is parallel to BC. What can you say about this angle and this angle? What type of angles are they? They are alternate or corresponding? They are corresponding angles. Therefore, angle P is equal to angle B, angle Q is equal to angle C. Corresponding angles. They are corresponding angles since the lines are parallel. Also, angle A is angle PAQ is equal to angle BAC is common. This is common angle. This is common angle for this triangle and big triangle. Therefore, by angle similarity, what is angle similarity? So if the angles of one triangle are respectively equal to the angles of another triangle, then the triangles are similar. Therefore, triangle APQ is similar to triangle APQ is similar to triangle ABC. See if the letters are coinciding or not. Letter P is coinciding with B, correct. Q is coinciding with C. A, same. Therefore, the triangles are similar. Since the triangles are similar, so if the triangles are similar, take the ratio. This is small triangle, this is big triangle. I am drawing sub diagram. A, P, Q, ABC. What is AP length is 2. What is AB? AB length is 6. What is AQ length? 3. What is AC length? 6 plus 3, 9. And this, now again, till here, until here, any doubts? Very simple. We have to consider this triangle and this ratio you have to take, and we are by converse of DPT, the triangles are similar. And now I drew the subdiagram. Therefore, from this, if two triangles are similar, the ratio of the corresponding sides is proportional. Two triangles are similar, the ratio of the corresponding sides are proportional. That means the ratio of the sides are proportional. That means AP by AB is equal to AQ by AC is equal to PQ by BC. See that we have to come to this conclusion. What is AP length? 4 by AB length. AB length is 6 is equal to AP length is 4, AB length. AP length is 2, I am sorry, here it is 2. 2 by 6 is equal to AQ length is what? AQ length is 3 by AC length 9 is equal to PQ by BC. Here 3 1 by 3 we are getting. 1 by 3 is equal to PQ by BC. Cross multiplication, BC is equal to 3 times PQ. So that's the problem. Very, very important, and it is somewhat related to numerical problem. So next question. Let D be the any point on side B. Let D be any point on the side AC of triangle ABC. Let us do another sum. Let D be any point on the side AC of triangle ABC. Let D be any point on the side AC of triangle ABC. D means any point here. And if E, F, G, H are the midpoints of AD, E is the midpoint, F is the midpoint, E, F, G, H. So look at this diagram carefully. E is the midpoint of AD and F is the midpoint of CD. Also G is the midpoint of BC and H is the midpoint of AB. If E, F, G, H are the midpoints of AD, DC, AB and AB. Something they are given like that. AB. HG is the midpoint of BC and H is the midpoint of AB. Or AB, respectively prove that EG is equal to HF. Once again I will tell, let D be any point of the triangle AC and E is the midpoint of AD, F is the midpoint of CD and AB and BC. AB means H here, something like that. G, H, it doesn't matter. G is the midpoint of AB and H is the midpoint of BC given. Prove that they are asking EG is equal to HF. EG is equal to HF. What you have to do is join AD. Join AD. So now since H is the midpoint and F is the midpoint, consider triangle BCD. Consider triangle BCD. H is the midpoint, F is the midpoint. So what is the meaning of this? H is the midpoint, F is the midpoint. The line segment, there is one theorem no, in 9th standard. The line segment joining the midpoints of the sides of the triangle, it is parallel to the third side and also half of the third side. Therefore, H and F are the midpoint given means, therefore HF is parallel to what? HF is parallel to BD. Also HF is equal to half of BD. HF is equal to half of BD. The line segment joining the midpoints of two sides of triangle is parallel to the third side and also half of the third side. That means HF is equal to half of BD by previous theorem. Next, consider triangle ABD. ABD. What is that? Now G and E are the midpoints. G and E are the midpoints of triangle ABD. Therefore, G is parallel to BD. G is equal to half of BD. Now from this 1 and 2, half of BD and half of BD are same. Therefore, from 1 and 2, HF is equal to GE. Because RHS are same, half of BD, half of BD. That means HF is equal to GE. Therefore, it is proved. Next one. In the adjoining figure, they have only given figure AD and BE are the medians of triangle ABC. AD and BE. AD and BE are the medians of triangle ABC. If DF is drawn parallel to BE, DF is drawn parallel to ED. Prove that EF is equal to CF. EF is equal to CF. Now here AD is the median, BE is the median, and DF is parallel to BE given. So use basic proportionality theorem. If a line is drawn parallel to one side of a triangle, then it will divide the other two sides in the same ratio. Consider this triangle. Very simple synonym this is RTP. Proof. Consider triangle BCE. Consider triangle BCE. Already given what? DF is parallel to BE. This is given, and AD is the median. Right? AD is the median. That means BD is equal to DC. Right? This is given. DF is parallel to BE, and AD is the median. Median means dividing the segment into two equal parts. So therefore BD is equal to DC. Consider triangle BCE. Now since DF is parallel to BE, this line is parallel to BE, therefore apply basic proportionality theorem. By basic proportionality theorem, CD by BD is equal to this. CD by BD is equal to CF by FE. But what is BD is equal to? BD is equal to CD. Both are same. One is equal to CF by FE. Therefore, CF is equal to FE. or CF is equal to A. Nothing is there in this problem, just AD is a median mean, this part is equal to this part. Consider this triangle, use BPT, this side by this side is equal to this side by this side, and therefore both are same, therefore EF is equal to CF. That's it. Very simple. So I think the remaining problems are little bit tough, means it will take lot of time. So I will prove in the next class. Thank you students, have a nice day. Please subscribe my channel and share to your friends so that they will also get more knowledge about this uh, similar triangles, tough problems as well as easy problems. Bye. We'll meet you in the next class. Bye.